Good morning to one and all. Myself, Dr. J. Namrata Manohar, is back with the 5th episode on tips to master computer programming. In my first episode, I had presented 46 queries or questions, the answers to which you should obtain and understand to lay a strong foundation for your programming skills and expertise programming. In episode 2, I had presented the preliminary terms of computer programming. In episode 3, I had presented answers to the first 20 questions as applied to C programming language. Hope by now you have set yourself into the programming environment. In episode 4, I had presented answers to questions 21 to 30 as related to C programming language. Let us now continue to progress with this 4th episode, in which we shall study the answers to questions 31 to 33 as related to C programming language. Since we are moving into the decision-making constructs, and by now we have got sufficient introductory knowledge of the language, we can start writing programs. Hence, in this episode, we will be covering only 3 questions, 31 to 33. And also, we will be seeing some questions related to your interviews or competitive exams as practice questions. Now, before we start this episode, I would like to just present the few videos that I have presented till now. They are importance of programming for electrical engineering, computer programming for beginners, fundamental terms of computer programming, make research thrilling, preliminary introduction to C programming language, embedded systems learning strategic approach episode 1, reading and writing skills to excel in life, profession and research, embedded systems programming strategic approach episode 2, introduction to C programming, second stage, and stress management, a situation to avoid. Now, since we are doing computer programming, you may, after this episode, once go through these videos of computer programming for beginners, fundamental terms of computer programming, preliminary introduction to C programming language, and introduction to C programming second stage. These episodes you may also go through after listening to this video. Now, our question, that first question was, what are the various operators supported by that particular language? Now, the various operator types supported by C language and certain examples are arithmetic operators, relational operators, logical operators, assignment operators, increment and decrement operators, bitwise operators, ternary operators, that is, which is same as if-else statement, which is the syntax is variable is equal to expression 1, question marks, value 1, colon, value 2. We will see how to use this in the subsequent slide. That is, say, int discount, you have discount, cost and price is 70. Now, how much discount you should give? So, if the price is greater than 60, then that is, if this condition or expression is true, then cost is equal to price into 1.1. That is, you are giving 10% discount. If it is not greater than 60, it is less than 60, you will be giving only 5% discount. So, price into 1.05. This is how you use this particular expression. Now, each of these expressions we will be seeing. Now, the first expression is arithmetic operators, that is binary arithmetic operators and unary arithmetic operators. So, the binary arithmetic operator, as the name indicates, it takes 2 operands. The various binary arithmetic operators are addition, subtraction, multiplication, division, and modulus. MODULUS, right? So, make correction here. So, here we will see, here 2 operand means it will take 2 variables or 2 constants. So, here we will see an example. If int A is equal to 9 and B is 3, then A plus B will result in 9 plus 3, 12. So, A plus B is 12 now. A minus B will be 9 minus 3, it is 6. Now, A into B, 9 3s are 27. A by B, 9 by 3 will give you 3. A modulo B, 9 by 3, the remainder is 0, so the output will be 0. Here we'll get 0. Now coming to unary operators, they will have only one operand. The unary operator will have only one operand, right? So unary minus, increment plus plus, decrement minus minus, not, address of operator, that is ampersand, size of operator. So here unary minus, that means B is equal to minus A. That is, you want to have B with the same value as A, but you want it to be negative. So B is equal to minus A. Then B is equal to plus plus A. That is, B is equal to B plus A. B is equal to B plus A. Whatever is the previous value of that, or we increment the value of A. So B is equal to, now say A was 6, now it will become 7. Decrement, you want to decrement the value. Not, B is equal to not of the expression. Address of, so here the advantage of C language is you can manage the memory. So that's why we have what is called as address of operator. PTR is equal to ampersand A. PTR is used for a pointer. A pointer is a variable that stores the address of another variable. Now say for example, here we have a variable A. It is stored in the memory location where the value of A is 9. So the address of this memory location is 1. So that means PTR will store the value 1. Size of, it gives you the size of the data type int. Now example, if int A is equal to 7 and B we have to find out. So B is equal to minus A. That means B is equal to minus of 7 because A was 7. B is equal to plus plus A. Plus plus A means 7 plus 1, 8. So we are taking this value 7, so it becomes 8. Suppose you take minus 6, right? You are adding one value, it will become minus 6. Now B is equal to minus minus A. So here, if we are taking the value 7, we have B is equal to minus 6, or if I'm taking B as 8 here, if you take B as 8 here, 8 minus 1 is 7. Now print A is not equal to B. That means we have A is 7 and say B is 8, but A is not equal to B, right? It is true. A is not equal to B. It is true. So the output will get as 1. If A is equal to B, it is 0 because it is false. False is represented as 0. Now, here we have, say, int A is equal to 9. We have int star PTR. This is the pointer. We'll be seeing in detail in the subsequent videos. But here I'm giving you, for example, I'm giving you one example here. Or int star PTR. Pointer is declared as star PTR. So PTR is a pointer. Now PTR, that means PTR stores the address of some variable. Address of which variable? So PTR is equal to ampersand of A. That means PTR stores the address of A. Stores the address of A. So here, what did I give you? A. A is stored in this memory location which has the address 1. So that means PTR stores the value 1. Right? Now here the last one, that is size of. We will see the size of int. We know that int is 2 bytes. So we will get the value of x as 2. Now here I have given some MCQ. Output, the output of an arithmetic expression with integers and real numbers is dash by default. Integer, real number, depends on the number used in the expression, none of the above. You may attempt this MCQ. Now, coming to the relational operators. Here we have equal to, right? A is equal to B. Now, not equal to. So, if A is not equal to B, then printf A is not equal to B. Less than or equal to, greater than or greater than or equal to. There will be many instances where we'll be needing these relational operators. So then accordingly we can use this. We will see some of them in our examples subsequently. Now, logical operators, logical and we have. So if marks is greater than 60 and marks is greater than less than 71, that is, it is up to 70. That means 61 to 70. If it is 61 to 70, then you are printing first division. Now, logical OR. That means marks in A is greater than 40 or marks in the subject B is greater than 50. Right? If it is OR, anyone, if greater than 40 or greater than 50, printf promoted. So, two subjects we are checking. If anyone in subject A you are getting more than 40 or in subject B you are getting more than 50, you are promoted. Now, logical NOT. If NOT of marks is less than 40, marks is less than 40, say assume your marks is 30, right? Marks is less than 30. So, it is true. But NOT of true is false, right? Since it is false, it will not print this. But say marks is 80. Mark 80 is less than 40. It is true, right? But NOT of marks is false, right? So it will print pass. Here I have given another MCQ. Void main int I is equal to 10 I, NOT of I greater than 40, right? Printf %I is equal to percentage D I. So what is the answer you have to give? Now continuing with our various operators, assigning some value. So the various assignment operators are equal to, plus equal to, minus equal to, star multiplication, star equal to, slash equal to. Now say we'll take an example. Int A is equal to 10. Then that means I've used this assignment operator. I've assigned the value 10 to A, right? Now, A plus is equal to 5. That is, it is equivalent to A is equal to A plus 5. These are all called as shorthand operators. Your strength or grip in the language will be known how you use these shorthand operators. So, in any language, if there are any shorthand operators, if you use them, they will know that you have a sound knowledge about the programming language. So, A is equal to A plus 5, A becomes 15. Now, coming to A minus equal to 5, right? So, here, that means A is equal to A minus 5. A minus 5. So, previously if A is 15, then it will become again 10. Now, A star equal to 5. That means A is equal to A into 5. Whatever is the previous value of A, say previous value of A is 10. 10 into 5, it becomes 50. Now, A mod x is equal to 5. That means A is equal to A by 5. That means here we have A as 50. So, 50 by 5 becomes 10. So, this is how you use your shorthand operators. Now, this will reduce the coding lines. By using these shorthand operators or assignment operators, we will be reducing our coding lines. Now, the last one is conditional operator or ternary operator. This is also a short form of if-else decision statement. So, here the syntax is variable is equal to condition. If this condition is true, it will execute this expression 1. If the condition is false, it will execute expression 2. So, instead of if-else, the more you use this ternary operator, the more the better, the lesser will be the lines of code. So, in programming, another objective, what we have to see is the logic should be simple and also the lines of code should be as less as possible so that the memory space occupied will be less in the coding memory area and also the execution will be fast. So, this is equal to if-else I have said. So, here we have say int A is equal to 50 and B is 30. Int X is equal to A greater than B. If A is greater than B, it is true. Then it will execute, it is the value of X is 40. If A is not greater than B, then the value of X is 13. So, here what are we having? A is 50 and B is 30, A is greater than B. So A is greater than B. So the value 40 will be assigned to the variable X. Now, coming to the increment and decrement operators. The increment operator already we have seen assignment. So plus plus or minus 1 used in two ways. That is, you can use it as prefix and postfix. For example, int A is equal to 5. Say A is 5. Then I will print prefix increment. A is equal to %D and I'm plus A. Since I'm using it as prefix, after incrementing, then A will be assigned, displayed here. So after incrementing, so A becomes 6. Now, post increment, if I say A plus plus, that means after using the value of A in this particular statement, then the value of A will be increased for the next statement. So here, since I've done post increment, A is equal to 6 only will be displayed. Now, coming to minus, pre-minus. So, minus minus A. So A is 6. So 6 output here. If I am considering this 5, right? If I am considering this 5 here, 6. If I had the value of A as 7, 7 minus 1 will be 6 here, right? A minus minus. A was previously already 6, right? So A but post increment, so it is 6 only, right? So that here why it is 6 here? A plus plus. So after executing this statement, 6 has become 7. 6 has become 7 because A has become 7. Since A has become 7 and this is prefix decrement, so 7 becomes 6. So in this statement also, it will be displaying 6 only. Now, here post decrement. So in this statement, the value of A used will be 6 only. But in the next statement, suppose I'm adding the value of A to another variable, then the value of A is equal to 7 will be used, right? So that is the difference between prefix and postfix. Now, similarly, we have bitwise operators, bitwise AND, which is performed on every bit of two numbers. That is, you convert the number into binary form and on every bit you are performing this AND operation. And as we know, AND, we know the truth table of AND. If both the variables are true, operands were true, then only it will display 1. So in the same way, here also it displays 1. Similarly, we have bitwise OR, we have bitwise XOR, here which is performed on every bit of two numbers. Next, left shift. Here you want to shift the bits by 1 or 2 digits. That is for data manipulation. Then you can also give by how many bits you want to shift the bits. Say you want to shift here, it takes 2 operands. One is left shift and how many bits? 1 bit, 2 bit, 3 bit. By how many bits you want to shift the digits also can be specified. So here we have left shift, you have right shift, and then you have bitwise NOT. In C, it takes one number and inverts all the bits in it. So if the number is 1, 1, it will display 0, 0. So this is how bitwise operators are used. Now, coming to the special operators, we have the comma operator, which we have been using till now. Printf marks is equal to %D, comma M. So this is how the comma is used. Then we have typecast operator, printf type. Reference operator of address of operator, which I have shown you in the previous example for pointers. It is used to give the address of a variable ampersand. Dereference operator or pointer operator star, double pointer operator. So in a subsequent videos, when you are doing in detail about pointers, we will see how to use these special operators. Now, the question number 32 was, how are expressions represented and evaluated? Now, most in the languages, the evaluation of the expression follows the BODMAS as in mathematics. And we also have to write the expressions in a particular format. Like if you suppose you have the expression 2ab plus 5x. If you just write like this, you will get an error while compiling. So how you have to write 2 into, you have to write like this, 2 asterisk A asterisk B plus 5 asterisk X. right? So this would give an error if you're writing like this in your program, but this will be executed. So writing the expressions is also an art, right? So how you have to use a square bracket, how you have to use a floor bracket or parenthesis. So here I have given you some expressions. Please write some C equations for this as you will be writing in your program, right? So you get a practice of how to write the expressions. Now, expressions are operated by the operator presidency and association of operators. The result is stored in the variable to the left. Now, the result after evaluating this expression, the value result is stored in this variable x. Operators with higher presidency are evaluated first. So also expressions with having high presidency operators are evaluated before expressions with low presidency operators. Now here say we have an expression z. We have the variable. Here we are having the variable z. Here a, b, c we are not calling as variable because they have already been assigned some value in the previous statement. So a plus b, a plus minus star are operators and a, b and c are the operands here. So we now know what is a variable, what is an operator and what is an operand. Here we'll just see an example program using this. Now int a is equal to 10, b is equal to 8. Then x is equal to a plus b star 2 star a by 5. So what will be the evaluation? Considering the mathematical board mass, since this is in the brackets, what is in the brackets will be evaluated first. 10 plus 8, 18 plus 2 into a is 10. So here you will get 20 divided by 5. So simplifying this, you will get x is equal to 72. So this is how the operator presidency is maintained. Now, in my previous video, I had also given you program design and development, operation research approach. So please, once again, I wanted you to recollect the methodology of writing a program. Step 1, read, study and clearly understand the problem. Identify the variables and constants. Identify the variables and constants. Identify the dependent and independent variables. Identify suitable names for all variables and constant, so that the moment you see your variable name and constant, you should know what it is. Say I give for velocity, I will give the variable v. V means velocity. So current means CURR I can give. So in that way, mass you can use MASS. So in this way, you should give suitable names for all the variables and constants. Now, if it is a technical problem, you make a list of all the various equations that you will be needing for that particular concept. Then step 6, decide on how to accept the input variables, display the result. That is, what type of data can be stored in that variable, whether it is character or string, int, float, double, and what type of output you want, what is the information you want from that, you should be able to first only decide. So you can write your appropriate printf and scanf statements. Then after deciding on the variables and the equations, you decide on the logic construct. That is, whether you will use for loop, if else loop, do while, array, switch, sub-functions, pointers, etc. and any other constructs which is provided in that particular language. Then finally, you start writing the code. So once you start writing the code, at every step, after a few steps, it's better you compile and check if you have made any errors up to there. After you if it is error free, then you add more lines. So repeat this process until the entire code is written. That is, do not write the code completely at first instant. Write it in blocks, compile, debug, and see if it is error free at each code block addition. So in this way, you'll be able to develop the program very fast. Run the program, identify any runtime errors and debug. Then finally, you finalize the code. Now, the question number 33, what are the various decision making and branching structures? So, and their syntax. So here we will be seeing this if-else statement. The various C decision making statements are if-else statement, ladder if-else ladder, switch statement and ternary operator. Ternary operator we have already seen, but again, once again, we will revisit it. Now, for the first one, we will take the simple if-else statement. This is called as simple if-else statement. Now, if test expression, then you have executable statement, right? Right. So, here, that is, if the test expression is true only, it will perform. So, here we have in hash include stdio.h main int a, printf, enter a number. If a mod 2 is double equal to 0, that is, we want to check whether the number is even or odd, right? So, if the number is even, it will be divisible by 2, we know. So, if a mod 2 is double equal to 0, printf percentage the number is a percentage the number is even, right? So here I'm not displaying the number here. I'm just saying a percentage the number is even. So here you have to give, comma. So what is the mistake here in this program? What is the mistake here in this program? Here I should give comma a. You should give, because I want the number 8 to be displayed in place of percentage d. So I should have given here comma a because of this a percentage d. Then a is equal to 8 is an even number. If I execute as it is like this, then it will give an error, right? So make a correction here. If test expression, executable statement, if expression is true only, it will execute. Now, next we have if-else statement. If here both true and false will be checking. If test expression, true set of statement, else false set of statement. So if this test expression is true, it will evaluate this block of statement. If it is false, it will evaluate this block of statements. So here we have So here we have hash include stdio.h, the program to find the greatest of 3 numbers. This is a very important program because it will be asked in many interview questions and also your competitive exams, right? So you have to learn this. You can write this program using if statement or while statement or using ladder. It depends on the logic you use. So they will judge you by the logic you will be using also. So here we have main. I've declared 3 variables int ABC. I'm saying printf, enter 3 numbers. So I'm accepting the 3 numbers A, B, and C. Now I have to check. So what is the logic? First I'll be checking the if A is greater than B. If A is greater than B, then what it will do? I have to check whether A is greater than C. So if A is greater than C, if A is greater than B, then I will check if A is greater than C. If A is greater than C, I will print A is greater. Else, printf C is greater. That is C. I have checked A is 5 and B is 3. A is greater than B. Since A is greater than B, I am going to this particular statement. A is 5 and 8. A is greater than C. Since A is not greater than C, it is false. It will print C is greater. Now, if A is not greater than B, since A is not greater than B, if here, because it is true, this block of statement is executed. But if A is not greater than B, that means A is less than B. So now I have to check whether B is greater or C is greater. So then we go and we'll enter into this block. If B is greater than C, printf B is greater, else printf C is greater. So in this particular example, We have 5, 3 and 8. So it prints C is greater. Now this is called as if-else ladder. If test expression, executable statements, if the first, you can test, you can evaluate many expressions here. So first we have expression 1. If expression 1 is true, right, then if expression 1 is true, whatever is written in this executable statement, it will execute. Otherwise, else if it will evaluate expression 2. If expression 2 is true, it will evaluate this set of statement. Otherwise, it will go for expression 3. Right? So in this way, all the expressions will be evaluated. Now, here we will just take an example here. So, percentage marks. I am checking based on the percentage marks. I want to display whether it is first class, second class, or third class. So, printf, I am accepting the marks from the student, right? If percentage of marks is greater than 79, I am printing distinction. Else, if percentage of marks is greater than 59, I will print first class. Or if marks is greater than 49, I will print second class. And otherwise, I will print failed. Right? So the output will be, now for example, I am accepting the marks. Marks I have accepted as 68. Now what is 68? 68 is, how is it coming? It's not greater than 79. So it will check here. It is greater than 59. So because it is greater than 59, it will display first class. Now, after seeing the if-else ladder, we will see what is called a switch statement. Switch expression of value. So you evaluate this expression or you consider this value. If the value is const 1, then it will execute this block of statements. That means this switch constant block 2 break does not match any of the default block, right? So here we will be just seeing this. Let us see one example. Here, program to accept a number between 1 and 7 and check whether it is display whether it is Sunday, Monday, Tuesday, or Wednesday, right? So here I have declared a variable num. I need only one variable, that is day of the week. So int num, right? Now I am saying printf, enter a number between 1 to 7. I will accept the number. Say I have accepted 5. Now I have to write the logic. I am accepting the number using scanf. Now switch num. This is the value or the variable. Case 1, printf Sunday, then I will break. Case 2, printf Monday, break. Case 3, printf Tuesday, break. 4, Wednesday, break. Case 5, printf Thursday, break. Case 6, printf Friday, break. Case 7, printf Saturday, break. Default. Printf wrong choice, break. So the output is enter a number. I have entered the value 5. So 5 means Thursday. So it will display the variable Thursday, right? So this is how switch is a very important statement. Number of interview questions will be asked regarding switch statement. Now, the last one is your ternary operator, which we have already done, discussed previously. Ternary operator I have already explained. It is a short form of if-else. It evaluates a condition, and if it is executes, one expression is executed, otherwise false. That is the syntax of this ternary operator. I have already shown you here. Here, variable, condition, expression 1, expression 2. If this condition is true, it will evaluate the expression 1. If it is false, it will evaluate the expression 2. So the advantage of ternary operator, one is it is a short form for if-else statement. So in if-else statement, if you are writing, you may have to write 4 or 5 lines of code. But using this ternary operator, you will be writing only one line of code. So in this way, you will be reducing the number of lines of code almost by 60 to 70%. Now, hash include stdio.h as usual. Int a, enter a number, accepting the number. So modulus of the number. So printf /n, a percentage d is an even number. That is question marks. If this is double equal to 2, a modulo 2 is double equal to 2, it will print a is even. Otherwise, it will print a is odd. Right? So here I have entered the number 19. So it will be displaying the value 19 as odd. Right? So this is how, or we can also give another variable here to display the value. Now, these are all suggestive. While executing this particular program, you may also encounter some errors to a practical problem in engineering, that is electrical circuits. So here we have a circuit where there are three resistors, R1, R2 and R3 are connected in parallel. So write a program to determine the electric current in the circuit as shown in the figure. Given that R1 is equal to 6 ohms, R2 is equal to R3 is equal to 2 ohms and voltage is equal to 14 volts. So here we open the main and declare variables for three resistances, equivalent resistance, voltage and current. So int R1, R2, R3 for the three resistors, volt. Float current EQ RES, equivalent resistance. Initialize equivalent resistance to 0. R1 is equal to 6, which is already given in the circuit. R2 is equal to R3 is equal to 2, already given in the circuit. Volt is equal to 14, already furnished in the problem statement. So we can compute the equivalent resistance of these two resistors R2 and R3 which are in parallel. That is R2 R3 by R1 plus R2. So EQRES R2 R3 by R2 plus R3. So this gives the equivalent resistance of these two resistors. Now this equivalent resistance is in series with R1, so we add them. So EQRES plus equal to R1. So we get the equivalent resistance of the entire circuit. Current is equal to voltage by EQRES. Printf current in the circuit is percentage amperes. So on execution, we will get the output as current in the circuit 2 amps. So in this way, we have to identify the variables and based on the data furnished in the problem statement, and accordingly design our logic and write the C program statements. So here I have given some review questions. Write a program using ternary operator to accept age of a person and print if eligible to vote or not eligible to vote. What will be the value of phi if x is equal to 8? Given phi is equal to x greater than 6, question mark 4:6. This is a ternary operator. So determine what is the output for this. If you have to make decision based on multiple choices, which of the following is best suited? So you have to select one of these options. Which statement accepts int, char, long, d? You have to, this is a multiple choice question, you select the option. Which of the following is an invalid if else statement? Options are given, you have to determine the right option. What is the output of the following program? Which important operator has been used in this program? So we have int main, int x is 4, int y is equal to plus x, printf x is equal to percentage d slash n, y is equal to percentage d slash n xy. So here int x is 4. So when we say int y is equal to plus x, so plus x, so y becomes 5. Now since we have said plus x, after this statement x also is 5. So when you display, you will get the value 5. What is the operator used? Pre-increment operator. What is the value of a? Int a is equal to 10 plus 4.867. This being an integer, you will get the output as only 14. This decimal part will be truncated. So in this way, you can try to solve many problems. Thank you. If you have any doubt, you can contact me on my mail ID. Thank you.